A very good morning to you all. We are here with the Power System Simulation Laboratory for the 7th semester, beginning with the experiments. Few of them are with the program-based experiments, namely MATLAB, Scilab, Octave, C++, like programming tools can be used to perform the experiment, and few of the experiment using dedicated power system software tools are put in the curricular requirement. In line with which, let us start with the early experiment using MATLAB as a scientific tool to experiment the power system simulation laboratory, beginning with the formation of Y bus by inspection method. As we are aware, power system analysis for various requirements like stability analysis, load flow analysis, fault study analysis, planning, prediction, and all. For all such things, definitely system representation in the form of mathematical terms that we call as physical interpretation of the system into Y bus or Z bus is very necessary. In the direction of the same, let us understand what is system admittance bus. Suppose you have a power system interconnected by transmission line and termination called as a bus. Then the transmission line, once they get connected from respective bus number 1 to 2, 2 to 3, so-called all interconnection, how do we represent this physical interconnection mathematically into a matrix form so that further computation regarding power flow and other studies can be done easily? Therefore, admittance form of representation of the elemental interconnection is performed using inspection method in this experiment. What is exactly inspection method then? It's also known as rule of inspection, ROI. It is as per the name, look at each bus one at a time and try to accommodate all the interconnections in the form of admittance and interconnections from bus 1 to rest of the buses in the particular positions of the matrix and build the matrix mostly by the inspection itself. Therefore, to understand that logic, let us take this simple problem. Formation of Y bus by inspection method given with the table of contains element number in the first column 1 to 5, from to 2 connectivity bus number 1 to 2, 1 to 3, 2 to 3, etc. Last one. It is connected by an elemental representation admittance. The fourth column represents like 1 to 2, bus 1 to bus 2, 2 minus J6 mo is the interconnection admittance. Likewise, I have all the information in this table. And you have input with the target obtain Y bus by inspection method. Then, looking to this information, let us understand what will be the dimension of the Y bus when I complete the task. The max number in this particular problem, moving to the column number 2 and 3, you will find 4. Then it clearly indicates Y bus when I obtain from this inspection method for this problem would scope 4 cross 4 matrix. Therefore, all these elements respectively be used to do that. Let us draw a graphical representation of this table of information. Considering the max number of buses as 4, let us put the node as bus 1, 2, 3, 4. Let us take one by one. Element number 1 is between 1 and 2. Between 1 and 2, I have to draw a segment representing the elemental data 2 minus J6. Similarly, between 1 and 3, you can see 1 and 3, 2 and 3, 2 and 4, 3 and 4. All these data were represented as per the table of information. Now, As per the rule of instruction, go to each bus one at a time. Consider all the radiating transmission lines from that bus to the rest of the buses. Some of the admittances must be taken and placed in the diagonal of the matrix position. As I said, this particular problem will find the Y bus output matrix as 4 cross 4. Then 1 cross 1 looks to be a diagonal, 2 cross 2 diagonal, 3 cross 3, 4 cross 4, etc. It means building up of the Y bus by instruction method, at the end we can see it looks like a 4 cross 4 matrix. The diagonals are the principal main diagonals. Other than that, off diagonal elements you will find on upper half of the triangle, lower half of the triangle in the output matrix. Then to obtain that, we should go bus by bus. At bus number 1, let us say to start with what is capital Y11, elemental representation in the output matrix. 1 means row number 1, column number 1 is equal to elemental primitive admittance of the line connected from bus 1 to 2 and 1 to 3. So it is Y12, Y12. In lower case, Y12, Y13. I should add these things directly, get the answer. Similarly, as I get in the first row, I have several elements. I could get this element. What about this first row, second column, first row, third column, first row, fourth column? In the first row, I am trying to convey. Then capital Y12 stands to be the first row second element, which is equal to Y21 because of the bilateral nature. Capital Y12 is same as capital 21, which is equal to negative of the admittance between bus 1 and 2. Admittance between 1 and 2 is given in the first line, 2 minus j6, whose negative Y12 when I write, it becomes elemental representation in the Y bus matrix position, first row, second column, same as second row, first column. This process has to be repeated. When I want to go first row, third column, I call it as Y13. Should be same as Y31, which is equal to like this, elemental data between 1 and 3, negative of that I have to write. Then it will be minus 1 plus j3. As I have no connection between 1 and 4, it is 0. I need not write it. So you might get a question, why minus is coming here? If you start working upon this particular problem in the theoretical interaction, nodal analysis when we work it out, we are sure to get the one negative sign for all those off diagonal representations. You need to recall that concept and you will get convinced. All the diagonals will have some of the admittances of the line radiating from that bus to rest of the buses, and off diagonals will have negative of the admittance connected to the rest of the buses from that particular negative we have to present. This logic we have to keep on continuing. This is about bus number 1. When physically I go to first bus number 2, at bus number 2 physically I find 2 to 1 there is a connection, 2 to 3 there is a connection, 2 to 4 there is a connection. There are 3 elements. I could see capital Y22 is Y21, Y23, Y24. Add the elements in the form of admittance directly and get the grand value capital Y22. As we were in the earlier step here, Y12 we obtained. What was Y21? Same as Y21. Means Y21 is Y12. No need to work for Y21 because what is being done? I move to Y23. Y23 is nothing but elemental data 2 to 3 connectivity. What I have? Element number 3. Negative of that I have to represent it. Then similarly 2 to 4. Is there any element between 2 to 4? There is an element. Negative of this. You can see both. Likewise, by instruction method, I should move to bus by bus. Account all the interconnections in the form of matrix, taking diagonal and off diagonal respectively. Has to be done. So once I complete bus number 2, I should move to bus number 3. At bus number 3, what I will get? 3 to 1, I have a connection. 3 to 2, I have a connection. 3 to 4, I have a connection. There are 3 terms. I should add them. You can see here. Node 3. Why 3, 3? Diagonal element. You might ask me why you are doing diagonal first. It's quite easy to know interconnection from this bus to rest of the buses. 31, 32, 34 elemental admittances. If I add, that becomes diagonal value Y33. Then, as I was speaking in the previous step, 3, 3 I am doing, no need to go 3, 2 because 2, 3 is same as 3, 2. And 3, 1, 1, 3 is same as 3, 1. Simply I should go next number to 3, 3. 3, 3, 3 next is 3, 4. 3, 4 is same as Y43, which is negative of the admittance between line connected between 3 and 4, which is in the table of information. 3, 4 is 2 minus J6. Hence, it will be minus 2 plus J6. One negative of which I should take. So, this way I could complete node number 3. Move to node number 4 or bus number 4. As you are aware, at this bus 4, you have a connection between 4 to 2 and 4 to 3. Therefore, we have only 2 lines. Now, I will come to this. What is Y44? Y42, Y43. When I add them, I will get a resultant 3 minus J9. What about Y41? Is same as 14. What about Y42? It is already being done at 2,4. It is being done. What is 4,3? It is being done in 3,4. Only one term is necessary in the final conclusion. And all these values, if I put in the matrix form, I will be able to get Y bus by instruction or rule of instruction as 4 cross 4 matrix. The diagonal says sum of the admittances of the lines connected from that bus to rest of the buses. Negative of the each element connected from bus 1 to rest is shown in the respective position. I would read 1 cross 2. It shows there is a connection between bus 1 and 2, whose negative data is minus 2 plus 6. Actual value is 2 minus J6. And 1 to 3, there is a connection. Minus 1 plus J3 shows off diagonal. Actual value is 1 minus J3 over there. And 1, 4, there is no connection. If I add them in the real value, real actual value, 2 minus J6, 1 minus J3, 0, that comes to the diagonal. So, diagonal is nothing but sum of the admittances of the line connected from that bus to rest of the buses like that. So, same thing is visualized here. Y22, Y33, Y44. We can visualize it graphically. This is how Y bus by instruction is performed from the basics. Once we are able to understand how to put all these together in the form of a flowchart and to make it in the form of program, how to do it? Let us take a simple concept. Formation of Y bus by instruction method. I start working, read all the data by the given problem, number of lines, number of buses, from where to where connection exists. What is that data? Is it an admittance or impedance like that? Now I check, is the line data is in the admittance form? Yes, then go ahead directly. If it is in the impedance form, what you should do? Convert it to admittance and use it. That was not discussed in the hand calculation, assuming that data is in the admittance form. If it is in the impedance form, I shall not take it granted. I should convert it to admittance and should use it. Then create. For the program to execute, you have to put all these information in the form of a data variable. Hold the information and use it as and when there is a need to extract that. I create Y data as a variable to hold content of the problem. Then I initialize. What is the output matrix here? How many buses are there in the problem? Maximum number of buses are 4, and 4 cross 4 is your matrix. Let us initialize Y bus as 4 cross 4, nothing but number of buses cross number of buses. Here in this n bus equal to 4. Then I should start collecting the information to assemble the values in the form of Y bus diagonal, Y bus off diagonal. For that to fetch the information, I should start loop operator, I as a loop, J as a loop to fetch the information from the variable Y data. Y data holds the information of the particular problem. It is arranged by the programmer. It is not given in the problem. It is arranged by the programmer to put the content of the problem in a format. That matrix is repeatedly retraced, so that on the retrace you fetch the information and assemble them in the form of a equation, and gets the representation as a value. Therefore, I use row operator as a I, column operator as a j. 1 to last number of buses. There are 4 buses, 1 to 4. J is also 1 to 4. Then I take the y data as a input data, which is actually an assembly of 4 cross 4 data. What is being done in this y data? Y data is entered with the information, the diagonals 1, 1, 2, 2, 3, 3, 4, 4 of that matrix personally put 0. 1 to 2 is elemental data 1 to 2. 1 to 3 is elemental data 1 to 3. 1 to 4 is elemental data 1 to 4 where personally written. Similarly, 2, 1, 2, 3, 2, 4, 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, 4, 3, etc. All the respective connectivity elemental data is placed in the respective positions in the y data variable in the form of a matrix. That matrix is traced using I and j operator, I being row operator, j being column operator. Then when I is 1, j can be 1 to 4. Once j is exhausted, I become I plus 1. Again j becomes 1, 2, 3, 4. Again I becomes 3, 4. Like that, it keep on operating iteratively inside the loop. When I is 1, it is pointing to the y data variable row number 1. And j is 1, it points first column. When j is 2, second column, third column, fourth column. Like that, when row is first, column is shifted 1, 2, 3, 4. When all the columns are traced, automatically row becomes row plus 1. I become 2. It will point to the second row. Again, j will start jumping from 1, 2, 3, 4. I become 3, 1, 2, 3, 4. I become 4, 1, 2, 3, 4. For all the j's. In this way, these two operators will help in the for loop like structure, in which I update y bus diagonal 1, 1 is initialized value, old value 0 in the memory plus y data I comma j. Whenever it is tracing y data variable I comma j, row number I, column number j, data is fetched. It is added to the y bus I like a manual operation. Then keep it updated. Then what is off diagonal? Y bus ij. So y bus ij is nothing but y bus ij what is initially minus y data I comma j. Because we know off diagonals are negative with the representation. This is one simple logic we prefer. There may be many methods to solve the problem. You can prefer it. So therefore, updating diagonal using old value, updated data of each element one at a time, one at a time, one at a time like that. And off diagonal one at a time, I am doing it. Once j is 1, is j is less than last bus number equal to last bus number? Yes, j plus 1, second column, update it. Next, third column, fourth column, complete. Is it the I last number? No, I become I plus 1. Then again j become 1, 2, 3, 4. Like that, every row when I is 1, j can span 1 to 4. When j is exhausted, I become I plus 1. Again j go 4. I become I plus 1. J become 1 to 4. Likewise, all the 4 rows, 4 columns were traced. I mean 16 elements, 4 cross 4 elements were fetched and put in this update equation so that the values of diagonal, off diagonals are updated, hence display the y bus and stop. This is how simply a flow chart, a simple flow of sequence for the computation of y bus is performed when it is understood. Similarly, when I want to program it, I require the program code, how it is being really programmed. So let us see. Meantime, I keep the MATLAB also working so that clear all variables. Clear all variables. Y data is stored with the information like this. What is y data? Y data equal to square bracket 1, 2, 3, 4. Row number 1. Semicolon 1, 2, 3, 4. Second row 1, 2, 3, 4. Third row 1, 2, 3, 4. Fourth row. I have 4 rows, 4 elements in each row. 16 elements are put. You can see here 1 cross 1, 0. 2 cross 2, 0. 3 cross 3, 0. 4 cross 4, 0. Personally made 0. What is 1 cross 2? Elemental data 2 minus J2. I will go back and show you. What is 2 minus 2? 1 minus 2? 1 to 2 is 2 minus J6. This is being written here. 1 to 2. 1 to 3 is 1 minus 3. You can just see. What is 1 to 3? 1 minus J3. So all these were located. It means 1 to 2 elemental data. 1 to 3 data. 1 to 4 there is no element. Again 2 to 1 is same as 1 to 2. 2 to is personally made 0. 2 3 is put with the data. And 2 4 is put with the data. And 3 1, 3 2, 3 3 is 0. 3 4 there is a line. And 4 1 is 0. 4 2 is already an element between 3 and 4. 2 and 4. 3 and 4 and 4. Nothing but Y data is such a way represented for the easiness in the computation. From the given table, you arrange this in such a way that it is very useful for you to read row by column. When I type it in the matrix, you will be able to visualize this. Then number of buses equal to 4, as you have seen the system. Then I initialize output variable Y bus equal to 0, n bus comma n bus. It means initialize with all the zeros 4 cross 4 matrix. If I don't do it, some of the unwanted garbage data will be displayed in the output matrix. I don't want to do it. I want to personally ensure zeros in all the positions. Only those positions I have to update, I will be updating in the loop structure. Hence it is done. Then, as I was telling, looping structure has to be done for loop operator row wise I equal to 1 to 4. And it is end outside, end and for. Within which nested for loop for j equal to 1 to 4 and here. What should be done? Update I comma I. Diagonal 1 1, 2 2, 3 3, 4 4. And 1 2, 1 3, 1 4, 2 1, 2 3, 2 4 like that. So this is going to update for me of diagonal and diagonal. So these two equations are such a way written when I is 1. J can have 1 to 4. Let us say I is 1, Y 1 1 equal to Y bus 1 1. Original value of this is 0 in the initial position. 0 plus Y data 1 comma 1. What is 1 comma 1? Go to first row, first column. What is the value here? 0. 0 is added to 0. And update the value of Y bus 1 1 is 0. Then similarly, let us say it comes back. J equal to 2. Okay. And J equal to 1. So let's take j equal to 1, I 1, 1. Again, it is same 0 minus this data. Then j becomes 2. It becomes y bus 1, 1 equal to y bus 1, 1, which is 0 plus y data 1 comma 2. What is 1 comma 2? 1 first row, column 2, 2 minus j6. 2 minus j6 is added to 0. You are trying to add one of the line admittance to the previous computed value. So you are doing like a human. What we did over here? When it is y12, y13. One line we added for next line. So this way 1, 2 I am adding. This is partial answer. 1, 3 I will add. That becomes total answer. In that way, program is doing. First it is added 1, 1, 0, 0. Mean 1, 1, nothing was there. 1, 2 got added. Then let's say j becomes 3. 1, 1 equal to you had a previous data non-zero plus 1 comma 3. 1 comma 3, 1 comma 2. When you add becomes grand 1 1. Likewise, first equation keep on updating diagonal 1 1 1 with all the j possible. 2 2 2, 3 3 3, 4 4 4 like that. What is about this one? This will be active and meaningful for you whenever I and j are not equal. This logic will help you. Otherwise, there can be some other logic which you can check. I not equal to j, then only you can perform this. So what I have done? 1 comma 2 by chance. What is 1 comma 2? It is a negative of the admittance between 1 and 2. What I am doing? 1 comma 2. Maybe original first time when I am passing the 0 in the memory minus I comma j 1 to 2. What is 1 to 2 elemental data? 2 minus j6, negative of that. I am writing personally minus of 2 minus j6 as an off diagonal. j is 1, j is 2, j is 3, j is 4. When I operate, for me 1 to 2, 1 to 3, 1 to 4 are interesting. When I is 1, I keep on updating all the values of 1 1, 1 2, 1 3. It means row number 1 is computed completely in I equal to 1, j equal to 1, j equal to 2, j equal to 3, j equal to 4. In that structure, I could complete using this equation and using this equation. When j is 4, it comes out of the loop. It goes up. I becomes 2. When I is 2, j can again have 1 to 4. I mean, I will be looking for second row, first column, second column, third column, fourth column content. I would mean I will checking for y22 in the first equation. What is that first equation? Y22 equal to old data 2 to 0 is uniquely 0 and 2 1. When I is 2, j can have 1 to 4. J is 1, 2 1, 2 2, 2 3, 2 4. Like that it is going to add it up. Therefore, this equation will help me to update y22 because there are 3 elements connected. It will have 3 loops. J1 is possible. J2 is not going to add because it is 0 addition. 2 3 is going to add. 2 4 is going to add. When it is added, it gives me y2. Similarly, when the second equation turns 2 and 1, y21, 2 and 3, y23, 2 and 4, y24. This will update the off diagonal 2 1, 2 3, 2 4. Likewise, second equation. When j is exhausted 4, I become 3. 3 with 1, 2, 3, 4. 3, 1, 3, 2, 3, 3, 3, 4 like that. It will work out for what diagonal? This will work out for off diagonal. When j is exhausted, I become 4. When I is 4, j can have 1. Why? 4, 4, 4, 1. 4, 4, 4, 2. 4, 4, 4, 3. 4, 4, 4, 4. This is not permitted for me. This way, these two equations under the for loop structure repeat such that all the 16 elements, I can say 16, 4 cross 4, it is 16 elements are updated and finally it is going to show you the display y. Now to execute this, what I will do, I will open up a MATLAB. Let us begin with the MATLAB coding to verify the process of instruction method using MATLAB structure. I begin with the new script file. I start taking the help of this help file which I have taken over here and I start assembling. Clear command line, clear all variable, all, and write the variable y data equal to square bracket 0 space 2 minus 6i space 1 minus 3i space 0. This is about the first row content. I'll make them space apart quite comfortably. Then I'll come to second row, which is 2 minus 6i space 0, and third element, which is 0.667, 0.667 minus 2i, and next element, I'll just make them little space apart properly. Next element 1, 2, 3. The fourth element in that 1 minus 3i. Then I come to the third row 1 minus 3i space 0.667 minus 2i space the third element preferably 0 and the fourth element 0 minus the fourth element, I'll just check it out later, 2 minus 6i. And the last row which I wanted to enter 0 and this is 4 cross 2 means 2 cross 4. I can check. Just I'll make the arrangement of the space properly. It will be nice to view. And second row 1 minus 3i, and the third element 3 cross 4, 4 cross 3, 2 minus 6i, and the last element is 0. So I will just check bracket complete semicolon. I will just check it out. 0, 2 minus I, 1 minus 3, 0, 2 minus 6i, 0, 0.667 minus 2i, 1 minus 3i, 1 minus 3i, 0.6672i, 0, 2 minus 6i, 0, 1 minus 3i, 2 minus 6i, 0. So I created Y data table as per the problem given number of connectivities from first bus to second bus, third bus and fourth bus to the respective. I just did it. Then I continue. I define number of buses in the system as per the problem. When I view the table, it is 4. I just enter and I initialize Y bus equal to 0, 0, bracket, n bus, comma, n bus. I just initialize just to ensure it is perfectly 0. Then I initialize for loop for I equal to 1 colon n bus, number of buses, because in this I have 4 buses, n is holding that information. Then I'll make n structure for this. In between I have one more for loop for j equal to 1 colon n bus, for which again I have n prescribed. In between I have a body structure y bus of I comma I, diagonal element equal to y bus bracket I comma I complete I comma I plus y data I comma j. This is what the logic I preferred. Then I have y bus of diagonal I comma j equal to y bus I comma j complete minus y data I comma j. This is to take care of off diagonal, original value minus the off diagonal data what I should write, and original value of I and y data. You can see similar lines I have mentioned here also. I referred them. Then when I do it, for loop ends over here, display y bus, display bracket y bus. That's all. So this completes the simple program of y bus by insertion method. You can see this is a y data is a table as we were interacting while studying the help file hand calculation, where 0, 1, 1, 2, 2, 3, 3, 4, 4. The diagonals were personally made 0 from the help file, and 1, 2 means 1 to 2 line information. 1, 3 means 1 through 1, 2, 3 line information. As 1 to 4 there is no data, it is 0. Likewise, all these elements from the help problem table were created for the easiness. Once it is put over here, looping structure, this for loop will fetch I is 1, it comes to point row number 1, j is 1, column number 1, j is 2, j is 3, j is 4, keep on jumping forward. Likewise, each time I shift row wise and j column wise, that will fetch the information of that location into this position, y data I comma j position, and it will be making an update on diagonal element and off diagonal element for our name. This is what is the short coding one would have done in the program. Now what I will do, I will just give name for this. Okay, what I will do, my lab program, I will write here my insertion method, then my insertion program, something, my insertion prog. That's all. Now, if I want to execute, I would like to see Y bus information. To do that, what I will be doing now, I will make command window side by side. I keep it side by side command window. Then I'll keep myself my help file also open. I'll open it up because I want to check the answers of that with the requirement. So I'll keep it up ready. Then I will just go down and I'll go to command window and I'll go to program window. I'm keeping ready. Then when I execute this, I should be getting run. Modify the path. I change the folder. Now you will see. So I have all the answers. What I will do now? I will maximize the screen and I will show because it's a 4x4 matrix. It's consuming larger space to display. I reduce the program size. Then I will run it once more. Run. Can you see here? Still it wants larger space. What I will do? Again, I will just make the program shorter and I will run it. Clear? It is showing me column number 1, column number 2, column number 3, column number 4. So when I run this code, it is going to display me the answer. So there is no error in this program. When I wanted to check the answer with the program, I could just see the answer from my hand calculation for this problem. What is the problem? Y bus by inspection method. Using this problem, I could do manually this kind of computation. You can see 3 minus J9, 3 minus J9. Diagonal, you can see. Okay, 3 minus J9. And you can see first row, minus 2 plus J6, minus 1 plus J2, 0. And all the values are matching with this. This is how Y bus by inspection method can be checked using MATLAB programming. So no matter, it is quite easy. Simpler coding structure would help you. These two are the important lines. Collect the information using for loop and dump in the variable Y bus. This is how Y bus by inspection method can be worked out. For you people, there is another problem just in the hand calculation page paper. Second problem, you can edit the content of this Y data table as per the problem and you can rework on this problem. Okay. Hope this you have got the answer. By chance, if you could do wrong entries over here, how you have to trace? You have to trace from your data table first. Then you have to check proper number of buses you have initialized or not. Then you have to check all the coding you have done properly or not. Now, if you just see some mistakes I'll commit knowingly, unknowingly, let us see how this will work out. Here, instead of I comma j, if I mention I comma I, let us execute. It executes. It executed and showed me some answer. But answer is not matching with your required answer. Then what is the problem over here? The problem is there is no syntax error. It is accepting. Y bus I equal to Y bus IIO and Y data I you mentioned. This way, it looks symmetrical. I comma I comma I comma I comma j, I comma j, I comma j. It feels apparently correct. But logically, I am not adding I am adding I comma j. So it should take us j shifting. It is not happening here. In this regard, there could be a small error. Instead of a j, if I type I, this should lead you a wrong answer. May you are not able to trace. Only when, personally, when you check what is happening with respect to each line, segment by segment, you will be able to trace it. So this one error, what I may get it. So I just correct it by mistake. By chance, if you mention, let us say j over here, what will happen? Let's say by mistake you typed j. Let us execute and see. Still it is running. You can see it is running, giving you some answer. But you are unaware of the fault. You are unaware of the fault, this showing you the error. So your answers will never match in this context. See, a silly mistake showing you some answer, but not the correct answer. You will be looping in and around here only. Therefore, you must be very, very careful about what exactly you are trying to do. Now I'll run it. See, it's working for your required answer. 3939 0 0. All the values are coming correctly for your requirement. This way, simple mistakes will conclude your wrong thing. The another way, when in the second line, Y bus I comma j, by chance if you do, so here also I commit a mistake. Here instead of I comma j, I comma I will enter. Let's see any error if I get. No error. You can see only diagonals are getting 3 3 3 9 3.6 11 3.6 11 3 6 9. only diagonals are getting updated. You can see this program which I just tampered it. Instead of I comma j over here, I comma I is running executing perfectly, no error at all. But showing you only diagonals are getting updated. Means second line is not getting updated for you. Is it clear? This way, knowingly and unknowingly, we may commit a mistake and we may conclude ourselves in this regard. Then, sometime what may happen, let me put that. It should be I comma j. It may happen, both you may type I comma I here also. Okay. What I did now? Instead of I comma j, I comma I did. That's what will happen. Still it is working. You can see this is running error free, but we have only some entries. Not all the entries are with the information. Many are zero. It's running correctly. Then who is wrong here? Therefore, you should be very careful about logic that you are using. So, in this regard, please be very, very careful about this. Suppose in this regard, one more mistake if I commit, I comma I. Let's see what will happen. Can you see? I am just showing 0, 0. What is happening? Here I am correcting, here I am subtracting. So, it's becoming null matrix. So, it's running perfectly. Logic looks very clear. Therefore, you should be very, very careful about the representation. So, I just modify. This is second line of diagonal. The first was diagonal. So, I should be very, very careful about my calculation. It shows me the answer. It means it should be fundamental in this. Suppose any wrong value, n bus, instead of getting this n bus, is wrongly typed by 5 for you. If I type it 5, let's see what will happen. Let us run and see any error I'll get. My goodness, I'm getting some error. What is this? Attempted to access y data 1 comma 5. Index out of bound because size of y data is 4 comma 4. What is the meaning? Where this error is noticed in the line number 15. I just click this hyperlink. Just click this. Here, when you are trying to update y bus 1, 1, y bus old data 0 plus y data 1 comma 5. When you wanted to take I equal to 1, j equal to 5. So, in that regard, you stuck with the j5. There is no j5. I is 1, pointing the first row. J is 1, j is 2, j is 3, j is 4. Where is j is 5? Fifth column is not there. In that regard, this is caught. And it says actual size of y data is 4 comma 4, but you are trying to address 1 comma 5. Fifth column you are trying to address, accessing it. It is not there. That's the error. Then what is the mistake now? The mistake is the range is wrong. So n bus range, what you mentioned, it would work provided I have another column over here. It might stuck somewhere with some other reason. If because rows are only 4. So 5 cross 5, I should make it. In that regard, this should be carefully seen. Suppose it should be 4 as per my problem. I just make it 4. Okay, it will run again, normal for my requirement. Suppose by mistake if you make it 3, let's see, it will run and what kind of error I'll get? I'm getting 3 cross 3 matrix. What is this actually? As per the problem, you should get 4 cross 4 matrix. But you are limiting it to 3 cross 3 because your loop operator is stopped with the 3 cross 3 only. Your loop operator is bounded to 3 rows, 3 columns only. It is not computing anything regarding the 4th column, 4th row. Hence, your n bus dimension over here might be wrong. This way, only by practice, you can get into. First is to make hand calculation on the paper, understand and try to implement it carefully. This way only we can make the thing comfortable to our understanding. So therefore, you should be very seriously see what is the size we should properly allocate. Now it's working fine. So therefore, no matter, it's a very simple program, but makes you fall into illusion if you are dimensionizing it wrongly. And one more thing I wanted to mention you. For loop, when I make 1 to n bus, what is the increment each time? This may be written in some coding, 1 colon, like this. It means 1 to last n bus, but for increment of 1 each. This central number shows increment of each one. When you do not mention that 1 to last number, default increment is 1. In that regard, I need not mention. If I mention also, it doesn't make any difference. It is going to be 1. Can you see the change which I have done here? This, if I run, I must get same answer. I am getting the same answer. It means increment of 1 in the loop jump is default in the MATLAB. So if I eliminate also, it doesn't make any problem. You can see 1 I eliminated, 1 I kept as it is. Still it got the same answer. So if I remove this also, nothing will happen. Okay, 1 colon n bus. Increment of 1 is default to me. So you can see the answer. This way you are going to work it out. Okay. Hope this program, simple program, made you comfortable and made you interested in learning MATLAB and practicing such coding in MATLAB for your laboratory application, and it might have inspired you to take up some good projects in the MATLAB workout. Okay. Thank you.